in what we call the electron cloud. Okay? How do you find the number of electrons? It is the same number as protons. Right? Because they are considered to be electrically neutral. What would happen if an atom if the number of electrons were to change? So can the proton number change? No. Can the neutron number change? Yes. Then it becomes an isotope. Can an electron number change? Yes. What does that happen? What happens then? It becomes an ion. So it becomes, trying to make sure we can see it. Or what we call a charged atom. It can be a positive charge or a negative charge atom, but it will be a charged atom. Okay? So let's come back over here and let's look at this. Element. What's the atomic number for hydrogen? What's the proton number for hydrogen? Helium. What's the atomic number for helium? 2. What's the proton number for it? 2. Carbon. Carbon. What's the atomic number for carbon? What's the proton number for carbon? Which should be the same, because whatever the atomic number is always going to be the proton number. Remember, that will always stay the same. It will never change. You are to fill this in. Let's go to the next one. Neutrons. Neon. Neon's in group 18, all the way to the right side of the periodic table. They told me that the mass is 20. What is the neutron number? How do I find the neutron number? I get the mass number. I take away the atomic number, like I did over here, showed you, and what's left over is a neutron number. Okay? But Miss Munson, this mass number doesn't match up with what's on the periodic table. It may not. Why? Because this might be a isotope. All right? So don't worry about that mass number when it's different, because it could be different. Why? Because there are these things called isotopes that are out there. Let's keep going. Electrons. Here's iron. They told me that it has a charge of neutral. What does that mean? That means it has the same number of protons as it has electrons. So how do I find the electron number? I need to find the proton number. How do I find the proton number? I go and I look at the atomic number. So whatever the atomic number is, that's the number of protons, then that's going to be the number of electrons. If it's a neutral atom, which we consider all atoms to be electrically neutral, do they stay electrically neutral? No, they do not. Atoms like to become ions. They like to become happy. Why do they want to be happy? Because they want to have what we call a full valence shell. Remember, the valence shell is the outside shell that holds those electrons. That's where all of the bonding and chemical reaction takes place at. Okay? So let's look at nickel, though. Nickel, they told me, has a +2 charge. Okay? If I have a +2 charge, that means I have 2 extra positive protons compared to negative electrons. Okay? That's what a +2 charge means. But here's where we need to stop and pay attention. Is this +2 charge means that I added 2 extra positive protons to the center of the atom? No, it does not mean that. Why not? Because I cannot change the proton number ever, ever, ever. The proton number is always going to stay the same no matter what I want to do. Okay? So what does that mean then? If I have a +2 charge, that means that 2 negative electrons left. They went somewhere else. They joined another atom somewhere else. So when we look at positive and negative charges, that is due to the electrons leaving or adding. So let's look at this one, +1 charge. +1 charge means that I have an extra positive proton compared to negative electrons. So I'm going to go to copper. Go find the atomic number for copper. Okay? Once you have that atomic number for copper, that number is going to be the proton number no matter what, because it's never going to change. But I have a +1, miss. I get you. But that means that instead of it being a neutral atom with the same number of negative electrons, it has one less negative electrons than it does positive protons, because the electrons can move, not the protons. A -3 charge means I have 3 extra negative electrons. So you find out what a neutral atom for silver is going to be, and then you need to add 3 extra negative electrons. You need to practice this. Okay? We definitely are going to go over this, but we do need to practice this ion, because this is something new that we haven't talked about yet in our notes. All right. Remember, on page 2, you're going to do this on your own. You're going to fill in this foldable, and you're going to cut them out, glue them, or tape them in. And you're going to answer those 4 questions to the side. Let's keep going. Ions and isotopes. Let's go ahead and go here so we can fill in this page together. And then we'll keep going. Okay, so let's go ahead and finish this worksheet here. And then on the other side is going to be for you to fill in on page 4. Okay, because we got to get through this. And you need to watch this video so you can finish this up. I think I've already extended it onto Blackboard to Sunday, but let's go ahead and just push it back. Since we don't have a lot of assignments due and stuff, let's push it back to like next week on Tuesday. So I'll go ahead, and when we have our meeting, I'll mention that. I'll also go ahead and post that announcement also for everyone. This is kind of a lot of work to get in, all right, regarding all the pages. If you work a few pages a day, then you should have it done by next week on Tuesday, okay? So let's go ahead and begin on this side. Ions and isotopes. Isotopes is a definition or a word that's in our notes that we've discussed during lecture. Ion is a new word. So I've talked about the word ion briefly on the previous page. It says here, what is the definition of the word ion? Ion is a charged atom. And what does the word charged atom means? It's a charged atom, meaning that it has a positive or a negative charge. Remember though, we consider all atoms to be electrically neutral, meaning that they have the same number of protons as well as negative electrons. But that doesn't happen in real life, you know, like things just don't always happen out that way. And the reason why atoms become ions is because they want to have what we call a valence shell that is full, or the outside shell needs to be full. Now, when they fill up that outside shell so they can be happy, that's when chemical reactions occur a lot of the times, okay? So a charged atom can become 2 things. One more time, positive or negative, okay? A cation, which is a word that we're going to use throughout the school year, which is probably a new word for you, is a positive ion. How does it become a cation? It forms from the process of when it loses an electron. Okay? It lost an electron. It loses an electron. So that means that it has more protons than electrons. Okay? Now, more protons and electrons. Why does it have more protons and electrons? Is it because it gained protons? No. It cannot gain or lose protons. Who did the moving? It was the electrons. So if it has more positive protons than it does negative electrons, that means that some of the electrons left. They went somewhere else. And electrons are not going to be just localized to that atom. Electrons can jump from atoms to atoms if they want to. Okay? Now, an ion can be a cation, or it can be what we call an anion. A anion is a negative ion. It forms, or it's formed by gaining electrons. That's how it happens. It gained negative electrons. So it has more electrons than positive protons. Okay? Again, it's not because it lost protons. The proton number can never change. Okay? Why or what happened? It's because the negative electrons were added. There was extra space in the valence shell. And with that extra space, it said, hey, we have some extra room. And there was some extra negative electrons hanging around. And so they jumped on over. Okay? One way in chemistry, how we remember it, is we say that cats are positive. Because cats have paws. You get it? Cats are positive. And so a cation is a positive anion. I'm sorry, a positive ion. Okay, a cation is a positive ion. Why is it positive? Not because it gained positive protons. It's positive because it lost negative electrons. So let's go ahead and look at this. We've seen this already, but we've seen it like this. For an example, here's copper, Cu. They gave us 65 and 29. But look at this though. It's a plus, 2 plus over here. This is a new way that you may also see it written. So remember how we said that this top number is going to be the mass number, which equals the protons plus the neutrons combined together. Don't forget this number right down here we said is the atomic number, which equals the number of protons, but it also equals the number of electrons due to it being a neutral atom. Okay? But if you see this is something extra now over here on the side, then this is actually going to be the charged of that ion. If blank, because nothing is there, then it's neutral. Okay? So if this is not there, because so far we've seen it without that, then that means that it's neutral. But if we start to see this, then that means that it is a charged ion, cation or anion. Okay? This one, what would this one be? A cation, because it has a positive charge. Remember, lost or gained electrons. So when we look at this one, did it lose or gain the electrons? Because the electrons are the ones that are doing the moving, not the protons. It lost. How many electrons did it lose? 2 electrons. Okay. How many protons are over here? 29, because that's what the atomic number tells me. How many neutrons are over here? 65. Take away 29 equals 36 neutrons. How many electrons are over here? Wait a minute. This is not blank. This has a +2 charge. So it should have 29 electrons. But look at it. It lost 2 electrons. So instead of the number 29, 27 electrons are going to go here. Is this an ion? What type of ion is it? A cation or an anion? It is a cation. We're talking about this one right here. Does it have more electrons or more positive protons? It has more positive protons because it lost 2 electrons. Okay? We got that? And that's what we're going to do over here. Alrighty? Now let's keep going. Isotopes. The definition of an isotope is atoms with the same number of protons which means that obviously it's the same element, but different number of neutrons. Okay? It says here, color the 3 isotopes of hydrogen. To the left, representing the correct number of protons, neutrons, and electrons. So let's see. It says color key. You choose your colors. I'm going to choose, because I have red. Protons are going to be red for me. I'm just going to use what I have here next to me. Neutrons are going to be yellow, because I have yellow. And I have a blue pen. Use what you have next to you. So, let's look. Hydrogen 1. Alrighty. This is going to be my electrons, which are on the outside. Hydrogen, he's on the periodic table, and his atomic number is 1, meaning that he has 1 positive proton. Is he ever going to have more than 1? No. Is he going to have less than 1? No. He's always going to have 1 no matter what. But for hydrogen 2, he actually has 1 neutron. Hydrogen 1 has 0 neutrons. Hydrogen 3 has 2 neutrons. Remember, the neutron number can gain or add as it ages. Isotopes of the same element have different number of neutrons. Therefore, they have different, what do they have different? They have different mass. They have different mass amounts. You can see it. The neutrons are going to change the mass to it. So it says here, let's practice a little bit. Just like we practice over here for ions, let's practice on isotopes. So here's my oxygen 16 and oxygen 17. What is that top number? It's the mass number. If it doesn't match what's the periodic table, it's okay. Why does it not match? Because it's an isotope. So what is the mass number for this oxygen? 16. How about this oxygen? 17. What is the proton number? The proton number is always going to be the same as the atomic number. Look, they both have 8. Remember that example that I gave you. When you get older and you get a driver's license, you're going to have the same driver's license number no matter what, as long as you age, whether you gain weight or lose weight. Just like my atoms up here. As they age, they gain weight, they lose weight, but they're still going to have the same driver's license number, which is the atomic number. Okay? So the proton number is going to be 8 for both of them because they are oxygen. It's the same thing. Just like you, when you turn 16 when you get your driver's license versus when you turn 36, you still have the same driver's license number. Your weight might be different, but you're still the same person with the same driver's license number. Neutrons. How do I find the neutron number? I get the mass number and take away the atomic number, and I get the number 8. Come over here though. 17 take away 8 equals 9 neutrons. The electron number. Remember, the electron number is always the same as the proton number if there is nothing over here on the side. Okay, if there is, then that means that that atom became an ion and it has a charge. This one has a -2 charge. How do I get a -2 charge? Could it be because I lost 2 positive protons? No, it cannot. Why not? Because my protons are going to stay in the middle no matter what. Who moves? The electrons. And if I have a -2 charge, that means that it gained 2 extra electrons. How many positive protons do I have? 8. Add 2 to it. That means that I have 10 electrons. Let's look over here. There's nothing here. Since there's nothing, then we consider this one to be electrically neutral. So if I have 8 positive protons, then that means I have 8 negative electrons. Okay? So again, I will take pictures of the worksheets as well to help you out. Or you can watch the video, rewind it, pause it if you need to. I'm expecting you to complete the practice page on your own now. We did page 5 together. And again, we're going to start using this to help us out when we're doing our dimensional analysis on mole conversions. Let's come over here to page 6 and let's fill this in. So on page 6, let me find my mole worksheet. A mole. Let's zoom in a little bit. Here we go. Is a counting unit. It is abbreviated as MOL and is a unit used in chemistry that allows us to deal with numbers of atoms, molecules, ions, or formula units and a sample of a substance, right? Kind of like we say a dozen eggs, and when we say the word dozen, you know that it's going to be 12. When we say the word mole in chemistry, that means 6.02 times 10 to the 23rd of whatever we're talking about. Okay? So just like a dozen equals 12 of something and a pair equals 2 of something, in chemistry, when we use the word mole, we mean 6.02 times 10 to the 23rd power of something, whether it's atoms, molecules, or formula units. Okay? In chemistry, the something refers to what we call particles, right? Those atoms or elements, right? Whether they're single or whether they're bonded together, right? Like molecules. Molecules are non-metal plus non-metal. Or whether we're talking about literally just atoms from the periodic table, or whether we're talking about formula units. Which we abbreviated as FUN. Fun. Okay? Now that Avogadro's number, 6.02 times 10 to the 23rd power, Avogadro's number, is a number that we pretty much memorize. Just like you memorize pi as 3.14, right? In math class, this is just a number that we memorized in chemistry class. What's another number that we've memorized so far? The density of water is 1. Okay? So there's a few numbers that you just memorize throughout. And this is one of them. Now, would you say a dozen pencils weigh the same as a dozen cars? Well, probably not. While the amount of both objects are the same, right? If I use the word dozen cars, a dozen pencils, we mean the same number of amount. Do we mean the same number of mass? No, we don't. We would expect that the mass of a dozen pencils and cars would be different, right? A mole is anything represented with the same amount, which is 6.02 times 10 to the 23rd power. But it does not represent the same mass for all substances. That can change, and that will change. And for us, when the mass of 1 mole is equal to what we call the where am I at? It says here that the mass is the link between particles and grams. Okay? The mass of 1 mole is equal to the molar mass, which is different for all things. Where do we get that molar mass from? I'm just going to put a little arrow over here. Periodic table. Okay? From the periodic table. So it says here, let's go ahead and do a little bit of work over here. Oxygen. 1 mole of a substance of oxygen. If I want 1 mole of oxygen, 6.02 times 10 to the 23rd oxygen atoms. How about 1 mole of bromine? Okay, well, it's 6.02 times 10 to the 23rd bromines. What about 1 mole of gold? 6.02 times 10 to the 23rd. What about 1 mole of H2O? Well, 6.02 times 10 to the 23rd H2O molecules. What about 1 mole of NaCO3? Again, 6.02 times 10 to the 23rd formula units. But again, all of those are about the amount of how many I have, whether I'm talking about a single one or whether I'm talking about something bigger. But what about the mass? Well, I would have to go to the periodic table, find the oxygen has a mass of 16 grams. So 1 mole of oxygen is this many particles, which has a mass of 16 grams. 1 mole of bromine is Avogadro's number, but the mass of 1 mole of bromine is actually 79.9 grams of bromine. So the masses are different, but the amounts are the same. Gold. If I want 1 mole of gold, I need to count out 6.02 times 10 to the 23rd particles or atoms of gold. But if I was to weigh it out on a scale, I would get 196.97 grams. Where did I get this number from? The periodic table. So you can see that the mass is different, but the amount of the substance is the same. Now, what if I want 1 mole of H2O? I've got to come over here. I've got to say how many hydrogens? 2. How many oxygens? 1. What is the mass for hydrogen? 1.01. So that comes out to 2.02. What is the mass for oxygen? 16, which comes out to 16. This comes out to 18.02. So 18.02 grams. So if I was to ask you, please go get 1 mole of water. You would go to the sink, you would pour 18.02 grams of water into a container. And when you measure it out, you would say, okay, Miss Munson, I just measured out some H2O, and here it is, 18.02. You would give it to me, and that would equal 1 mole. And if I was to be Miss Frizzle and make us all small enough as the size of molecules, we would sit here for days and count out every little molecule of H2O until we get to 6.02 times 10 to the 23rd power of molecules, which would be equal to 18.02 grams. Do you see? Again, the Avogadro number, which is the amount or substance, is the same for everything, but the mass, which we get from the periodic table, the molar mass, is different. Again, how do I compare that to? If I ask you to go get a dozen pencils, you go grab a dozen pencils, and then I ask you to go get a dozen cars, you would have the same amount, 12 and 12, but the mass would be different, obviously. Same thing here. You need to finish this one as part of your assignment right here. Go find the molar mass of sodium carbonate. Use the periodic table. Turn the page. We're not done with our notes. So let's keep going. Moles. Says are useful conversion factors. 1 mole is equal to Avogadro's number. 1 mole is equal to the amount of molar mass of that substance. We can write this conversion 2 different ways. So look at this. We can write it one way or we can write it another way. Let me find my paper. There it is. So I can say 1 mole is, remember that division line means equal. to Avogadro's number, 6.02 times 10 to the 23rd particles. Or I can say 6.02 times 10 to the 23rd particles is equal, that's what that line means, to 1 mole. Okay? So this one right here, I wrote it this way. And I wrote this way. Or I can say 1 mole is equal to the molar mass in grams, or I can say the molar mass of whatever we're talking about in grams is equal to 1 mole. So I can flip it if I need to. So I just said this right here, or I wrote the same thing here, the second line over here. Okay? So let's practice doing our dimensional analysis conversions. How many grams are in 2 moles of NaCl? First thing, what do? I like to underline what they gave me. 2 moles of NaCl. What am I looking for? Grams. That's my question mark. That helps me out when I'm doing my dimensional analysis. What is step 1? You always write down what they gave you. What did they give me? They gave me 2 moles of NaCl. Remember, we do our little thing, our crisscrossing, like algebra class. For me to cancel this out, I've got to put the same thing at the bottom. So I'm going to write mole of NaCl. So here's where this would help you too. This little page number 5 flip chart. I've got, what do I have? Moles, and I'm going to grams. Come over here. Which one goes from moles to grams? This one right here. Flip it open. How does it look like? You put your given moles, which they gave me 2 moles of NaCl, and I put down here 1 mole of it equals the molar mass in grams. Do you see how this helps me? And where do I get the molar mass from? The periodic table. So I'm going to come over here. I'm going to say Na, sodium, and chlorine are the elements I've got in my compound. How many NAs do I have? 1. How many chlorines I have?